to know that. I heard that from our Pro Vice Chancellor, Professor Ajak, that you are also thinking whether we can go for some kind of collaboration with your institute. So could you please say something on that, the possible areas that we can go for?
Yeah, definitely. You know, I'm the delegate of my rector to international relations. So I'm working since many years in establishing new agreement between my university and the foreign university. So I established many agreements with, you know, US, Europe, Africa, China, and, you know, it's my pleasure, you know, to promote our future cooperation. So, you know, the very first step could be to sign a memorandum of understanding, and then hopefully we could work on it in order to create some, you know, exchange of students or researchers. So this is something that is really appreciated by my rector, and of course by myself, because you know, we push you know, to gain internationalization activities, you know, with many different universities in the world. And I think that your university, you know, is a very good one. And then also your professor Abdur, you know, we are in touch since some years, so we published some joint paper. So let's work on it, because I guess it could be very interesting for both of us.
Thank you very much for your good comments. So we are also keenly interested to have some kind of collaboration. So we have also got one internationalization center. So we can initiate the process of having a collaboration through establishing MNU with you, right? Memorandum of understanding with you. So in that case, should we send the format or you will be sending to us?
I just sent you our template. Of course, we can modify it according to, you know, your needs, no problem. Okay. So usually it's a very light, I would say light one, in the sense that we don't take any obligations, okay? Oh, it's just an MOU, so something very light, but if you'd like to add something or to change something, feel free to do it.
Okay, thank you very much. Professor Ajak, do you like to say something on this issue?
Yes, Professor Giancarlo, we are really very happy and we do appreciate your valuable time spending here for the Bangladeshi researchers. And definitely you have showed interest about the University of Bangladesh, and you have already mentioned that we have been working together for a few years on research purposes. Eventually, today noon, we have received major revision of a research paper that we are working on. So it's really highly appreciating, and definitely the way in which you are thinking, we will be working on that, and we'll soon send you a feedback, and definitely we'll have a separate meeting with you. And if you want to keep there any other additional professors or some persons over there in the meeting, so you can also put there, and we can have a meeting very soon in the next week or the next week.
Okay, great. Yep.
That's great. Yeah.
Professor Giancarlo, what is the time now in your place?
It's almost 5 o'clock p.m. Okay. It's 5 o'clock.
4 hours difference. 4 hours.
Yeah, 4 hours. 4 hours. Yes.
Corona, how is the situation now in your place?
You know, in Italy, in the South Italy, the situation is very good. So in the South Italy, we were not affected so much. Oh, the North Italy was affected a lot. The North Italy, Lombardia, you know, Milan area and Turin area. But in the South, specifically Calabria, we were affected just a little bit, fortunately.
In your university, are you delivering lecture through online, or you're still?
Yeah, no, the second semester was fully delivered online. Now we completed the second semester. We are in the exams period. and we will restart our first semester end of September, and very likely in a blended way. So partially online, partially physically. We are organizing ourselves, not so easy as you can imagine, you know. So, and but anyway, this second semester was pretty good because you know, the online delivery worked pretty well.
Thank you. I could see Dr. Fahim Kausar.
Yes,
Hello.
yes.
Good evening. How are you, Dr. Fahim?
Hello, everyone.
Can you hear me?
Yes, can you hear me?
Yes, I do. Thank you. Thank you for joining with us.
I'm expecting my colleague will join soon.
Yes, we are waiting for Akhil Mathur to join here. We can hear you very nice. Professor Fahim, could you please test your PowerPoint slide, whether it is appearing correctly or not?
Sure.
Yeah, yeah. Oh, yes, we can see now.
Yes.
Yes, it's quite visible.
All right, perfect.
Yeah, that's great. Yeah, so Professor Fahim, you can now close your sharing.
All right, perfect.
Professor Fahim, what is the time now in your place?
So I'm based in Cambridge. So Cambridge is 4 o'clock now. So we are a couple of minutes away from 4. So it's a very nice time in the afternoon. It's been very warm and humid here for last few days.
Okay, great.
How about the corona situation over there in the city?
The UK situation, it's not very good. I think, of course, the country has reopened last week, couple of weeks back, but the infection rate and the death is not necessarily reducing. I think even yesterday we had over 115, I believe was the correct number, and over 1,000 infections. So it's not necessarily coming down. And the fact that the weather has been very good, so people are basically not following the rules and regulations and going for outdoor activities, which is actually causing more trouble. So the expectation is that we're going to see a second wave within the next, I think, few weeks' time. That's the expectation right now.
Professor Giancarlo, let me allow to introduce Professor Fahim Kausar. He is from Nokia Bell Lab, Cambridge, and he is originally from Bangladesh and now working over there. And Professor Fahim Giancarlo is from University of Calabria, Italy. Yeah.
Nice to meet you.
Hello. Nice to meet you. I think my other colleague Akhil should be on. I see his
Yes.
logo is on. So Akhil, are you online?
Yes, I'm here. Hello, everyone.
That's great. Welcome on board.
Hello, Dr. Akhil. Welcome. Joining with us.
Thank you. Thank you very much. Very, very nice to be here.
Thank you.
So it's about 8:59. We'll shortly start the session. Dr. Aminur,
Sir,
have you set all the technical issues?
yes, everything is okay.
Okay. Few seconds only. Bismillahirrahmanirrahim. Dear participants, Assalamu alaikum, Namaskar, and very good evening. I do welcome you all to our first session of the lecture series organized by IEEE Computer Society, Green University of Bangladesh Student Chapter, and IEEE Student Branch of Green University of Bangladesh. And it is also supported by IEEE Computer Society Bangladesh Chapter. Today, we have amongst us Professor Dr. Ghulam Samdani Fakir, the Honorable Vice Chancellor of Green University of Bangladesh. We do have Professor Giancarlo Portino from University of Calabria, Professor Fahim Kausar from Nokia Bell Labs, Dr. Akhil Mathur from the same institute, Nokia Bell Lab. Myself, Mohammad Abdul Razzaq, Pro Vice Chancellor of the University of Bangladesh, and
me, Dr. Muhammad Aminur Rahman, Branch Counselor, IEEE Student Branch, Green University of Bangladesh.
will be with you to chair this session. Respected professors, graduate research students, and industry professionals from 30 plus organizations have registered this session. Already we are seeing that around 40 participants are here, and we do believe the rest are joining us soon. Today we are here to discuss on the powers of sensing, artificial intelligence, and the related computing technologies to reduce further spread of COVID-19. May I now request Professor Dr. Ghulam Samdani Fakir, the Honorable Vice Chancellor of the University of Bangladesh, to put his short opening remarks.
Thank you very much. At the very outset, I would like to welcome all of our distinguished speakers. It's a great opportunity for us to have with us. And I know that this is a technical term that we are going to use, and I'm a non-technical person, so I may not be able to say anything on the topic, but I'm willing to learn from your presentations. But I really emphasize that this is a timely initiative that is undertaken by our CSC department. And I really appreciate Professor Abdul Razzaq, our Pro Vice Chancellor, and Dr. Muhammad Aminur for chairing those sessions. And we are looking forward to listen from you. So with these short words, I would like to welcome you once again. And please, you can start your presentation based on the previous schedule. Thank you. Thank you very much.
Thank you very much, sir, for your nice comments. Now it's time to hear from Professor Giancarlo Portino. He is from University of Calabria, Italy. Professor Portino is his co-founder and chief executive officer of Sensiscal, a spin-off of University of Calabria, which is focusing on the development of innovative systems and services based on Internet of Things. He conducted research projects of €3 million plus, and he published 400 plus research articles, and he has a high impact factor, and he is known as the high impact researcher in the community according to Scopus and Google Scholar. You can search about his detail in the Google. I'm shortening his biography. So may I now welcome Professor Portino to start his presentation.
Okay, thanks a lot for your presentation. I will share my screen.
During the presentation, all participants are requested to listen, and you please raise your hand should you have any question after his presentation. I will ask and call you to receive anything. Please mute your microphone when Professor Portino is delivering his lecture. Please mute your microphone. Thank you.
You are able to see my slide, right?
Yes, Professor.
May you?
Yes,
okay.
Yes.
Okay. First of all, thanks a lot for your invitation. I appreciate a lot, and specifically because it gives me the possibility to speak about, something that on which we have been working for a lot of time, and now we are applying in, a new situation. Unfortunately, the COVID-19 introduced many issues all around the world. Is a really, pandemic effect. And we thought a lot how to reuse some of our recent research and turn such research into something that could be of support to future pandemic events. So the title of the talk is related to collaborative body sensor networks as enabling technology for implementing social distancing and human tracking. So this is the outline. We'll give you just a very brief introduction to body sensor networks, specifically wearable body sensor networks. Then I will introduce the concept of collaborative body sensor network. I will show you our framework, cyber-physical framework, named C-Spine. I show you a prototype, a real prototype we developed using C-Spine. And then I will try to contextualize the use of collaborative body sensor networks in the current pandemic event by proposing a system we are going to develop. So I will discuss about the requirements of such systems with respect to the current state of the art of methodologies and tools currently exploited in order to deal with social distancing and humans tracking. Then, of course, I will conclude my talk with some remarks and, some related to our ongoing work. First of all, what is a wireless body sensor network? For sure what is a wireless sensor network. It is a wireless sensor network applied to the human body. So you could have one or more wearable sensors. You can attach such wearable sensors on your body, and such wearable sensors are able to create even a dynamic network coordinated by a base station. That could be a laptop, could be an environmental computer, could be your smartphone, in order to support different applications like healthcare, fitness and wellness, emotion and stress recognition, interactive gaming, even social interaction. So you see several sensors on the human body. They could interact even with each other, okay, in a peer-to-peer way, but usually they interact with a gateway, and the gateway is able to collect data from, the gateway is able to program the body sensor network, okay? And the goal is to deliver services. Which kind of services? Activity monitoring is one of, the most famous service provided by a body sensor network, fall detection, or even gesture recognition, emotional stress analysis. I will show you the very first handshake recognition system we developed some year ago with TU Berlin in Europe. And of course, you can use for rehabilitation of patients and many other purposes. You see that there are many different sensor platforms around. You can build your own sensor platform, even though in our opinion, it's better to use some already available commercial platform. You see at the bottom of the slide different kinds of sensor platform, from Telos B to Sunspot, Mica Z, Wasp, Shimmer, and other sensor platforms. Specifically, Shimmer is produced by an Irish company in Ireland, in Europe, and it is purposely produced in order to deal with the body sensor network, and it works pretty well, even for prototyping, but also for the final, let's say, commercial product. Okay, it's important to note that in order to develop systems based on body sensor network, you know, the programming of body sensor network is a very complex task, In fact, you need to use low-level software abstractions. You need to use constrained architecture from computational capabilities, from the network capabilities, even from, you know, the storing capabilities and the energy point of view. And then you have to be able to create even embedded application that could have, could use a lot of resources, could implement even sophisticated data mining algorithm or machine learning algorithm, and they need also to preserve security and privacy. Okay, so it's pretty complex to develop body sensor network based systems. What we achieved so far, we proposed an approach that is called a domain-specific framework, and our framework, specifically SPINE, that stands for Signal Processing Node Environment, is an embedded framework able to develop applications partially running in the node and partially running in the base station that could fulfill different requirements, and that stands in the middle between a pure application-driven approach that is very efficient but not so effective, and at another extreme, you could have a general purpose middleware supporting creation, development of application based on body sensor network that is, you know, general purpose middleware, very effective but not so efficient. So our approach is in the middle, so it is able to provide efficiency and effectiveness. Okay, let's start from our framework that is indeed an open source project. You can connect to our website in order to join our community. The very first version was developed many years ago. It was a joint development effort between my university, University of Berkeley in California, Telecom Italia, and other stakeholders. So the product, again, is not a commercial one, it's an open source product. You can connect to the website, or you can refer to, you know, the most cited publication. It is a highly cited paper in Web of Science, and also received an award, a pretty important award from the System and Cybernetics Society. So in this paper and in this book published by Wiley, you can find, you know, many details related to SPINE. Now I'd like just to point out some of, you know, the characteristics, the features of the SPINE framework in order to develop body sensor networks application. As you may see, SPINE provides a service discovery. So your network, your body sensor network could be fully dynamically discovered. So each sensor could provide information about the sensing capabilities, the actuating capabilities, or even the computation capabilities. Then the system is able to provide flexible sensing setup. So you are able to program your sensing activity in a flexible way, enabling both raw data collection and preprocessed data collection, because you are able dynamically to inject signal processing function inside the nodes, and then calculate, let's say, different kinds of preprocessed data, but also you can inject even more complex classifiers in order to compute in node specific, let's say, machine learning activities. Then, as soon as you are able to collect your data, again, raw data or preprocessed data or processed data, at the base station side, you can perform high-level data processing using whatever, you know, algorithm in whatever language you'd like to use. For example, Spine is also connected to Weka, to NIME, or to other machine learning based tool like Python or alike. And it's important to note that Spine is extensible. It means that you can extend its characteristics and you can customize its features. Another point is security. Currently, Spine supports some encryption algorithms, specifically hardware encryption algorithm, but you need to have specific sensor platform in order to run the security algorithms. We are working also in the direction to use different customizable security algorithm and also privacy preserving algorithm. But this is, as we like to say, it's another story, okay? Another point was that Spine was virtualized. So if you'd like to create communities of body sensor networks, it means not just being able to monitor a single, you need to exploit cloud-based features. So we proposed the Body Cloud. You see here the address of Body Cloud. So you can connect, anyway, Body Cloud is an open source effort. So you can join again the community. And the Body Cloud is able to virtualize body sensor networks and virtualize applications based on body sensor network using even a sophisticated software engineering approach. So at the end of the day, you could, in a very easy way, create new body sensor network community application in order to monitor your group of users in many different application domains. Using Spine, using Body Cloud, we were able to create different application. I would say a wide range of application, going from sport application, application at the office, application at the hospital, application at home. Different application able to monitor people based on body sensor networks. Okay, so this is something that you can find in the paper I mentioned earlier, and also in the IEEE Press Wiley book. So you can have more details about the application we developed. Now, what's the problem, in my opinion? In my opinion, right now, in order to, let's say, combat fighting COVID-19, we are producing a set of applications mainly based on smartphones or smartwatches, okay? And such applications, in my opinion, are very limited in functionalities in order to deal with an effective and efficient monitoring of a real, let's say, pandemic situation. But let's think about what we could do by using body sensor networks, and then in which way we could reuse body sensor networks in order to support new tools. I don't want to say that such new tools will be available in a little while, of course, but maybe we need to start now in order to have in a near future, maybe for a second wave or a third wave, a fourth wave, or in the future, new tools much more effective, much more efficient in order to combat, to fight against new pandemic events. So another point in my talk is related to multi-user activity recognition. So in my opinion, it's not enough to understand how close we are or how many we are in a given place. We need to understand also the activity or the activities we performed or we are performing in a given area in order to understand better what's the potential of virus transmission or whether or not there is any danger in such transmission. So in my opinion, the normal contact is not enough in order to create a very effective tool. And here it comes, you know, our idea to use multi-user activity recognition methods based on different tools. Of course, we promote body sensor networks, but we could also use, let's say, other tools like, you know, cameras, like different devices, environmental devices, for example, and of course, body sensor networks. So the idea here is to be able to detect and also classify group activity. If people in the group is competing or if people in the group is collaborating, think about a football match or think about people watching a football match, okay? Or even, you know, multi-individual activity or hybrid activity. I'd like to understand if I go cycling, I go jogging, or I'm doing something else, cause very likely the virus spread context to the different activities we are going to perform or we are performing. So this is an important point that we need to explore, not just again for having something right now, but maybe, you know, in the near or in the future pandemic events. What are the open challenges? There are many open challenges on multi-user activity recognition and classification, because mainly the research was devoted, at least the research so far, was devoted to single user activity recognition. You have a lot of papers, you have a lot of prototypes. I would say well-working prototypes, able to detect and classify very accurately, sometimes even with an accuracy that is almost 100%, single user activities. But if you like to detect and classify multi-user activities, this is another matter of fact, and there are many different open challenges. Challenges related to multi-sensors, collaboration, data acquisition, and synchronization. Challenges related to human-to-object and human-to-human interactions. Challenges related to how to identify groups and how to recognize groups in open context, how to predict multi-user activity, and how to exploit augmented reality along with Internet of Things in order to provide more information. And of course, there are several papers, not so many as single user activity recognition, but a good bunch of papers, mainly focused on computer vision. There are few based on low-level informations like channel state information or signal strength information, and less on the use of body sensor networks. And in this context, we proposed collaborative body sensor networks that are body sensor networks able to interact with each other, to collaborate with each other, to cooperate with each other in order to provide information related not just to a single user, but to multiple users, and to provide, let's say, services to multiple users. In the paper you see on the bottom of this slide, you can refer to this paper. This paper was published in 2015. I guess it's a reference for collaborative body sensor network. It is also an highly cited paper in which we proposed the architecture of a body sensor network and its first implementation using an extension of our framework spine. So you can see two body sensor networks interacting with each other. There is a process of interaction. In this process, body sensor networks need to beacon themselves in order to make them be discovered by other collaborative body sensor network. Then we need to have some service discovery of the services that such kind of body sensor network are able to deliver. And also we need very low level mechanisms in order to say, okay, I'm very close to you. I'm just close let's say 50 centimeters or 1 meter or 4.5 meters. So we need sophisticated techniques at low level that are able to provide us with information about distance, much more fine-grained than the information that, you know, Bluetooth or let's say low power Bluetooth is able to provide us, okay? If you use IEEE 15.4, that is a personal area network, very likely you could have more, let's say, fine-grained information about distances and even about multiple body sensor networks or multiple people in your specific area. And of course, we developed extended indeed spine with all the blocks we need in order to detect proximity, in order to enable inter-body sensor network communication, in order to provide collaborative body sensor network services, and also at the top, you can see at the top, at the base station side, collaborative applications. And in our opinion, the new applications able to fight pandemic events should include all the basic building blocks our collaborative body networks are able to provide. Currently, we developed a system that is called the hands system. Is able to detect handshake between people. For example, also the handshake is a dangerous, let's say, gesture able to spread virus. And this is pretty common in Europe, because in Europe, as soon as you meet someone, or in the Western world, as soon as you meet someone, you shake his, her hand, okay? And this could cause virus spreading, okay? So we need to understand if we shake our hands or we just waved goodbye or waved ciao, for example, okay? Without any contact. So I could be at 2 meters of distance and then I can say hello, maybe nothing could happen, but I could be very close, even at 1 meter of distance. But if I shake, you know, a hand at 1 meter of distance, you know, the danger is pretty high. The risk is very high that I could transmit something. Okay, so I need indeed not just to detect proximity, but I would need to detect even the action involved. Okay, so this is just a demo. I'd like to show you a very short video demo about our system, that is the C-hands systems. Here it is. Okay. This system was developed with my colleague from TU Berlin, specifically the group led by Adam Wolitz from Technical University of Berlin. And in order to create this system, we just used 2 body sensor networks. You just see sensors that are worn on the wrist of people. And then we are able to understand whether or not a real handshake is or could be detected in this case, this is not an handshake. You don't have any touch. So this is a potential handshake, but not a real handshake. This is just a movement from one side. That is one side potential handshake, but not a real handshake. And indeed, this is a real handshake, the handshake. Okay, I'm going to complete, to finish my talk, saying that in the world, there are a lot of efforts related to implement tool-based mechanism for social distances. During this, COVID-19 pandemic event. Many countries around the world, like Israel, Taiwan, South Korea, Singapore, India, Italy, and many other countries, are using different tools, mainly based on smartwatches. Okay, they are mainly based on smartwatches and on positioning APIs provided recently by Google and Apple, and using, in indoor environment, Bluetooth radio. Okay, what's the problem in our opinion? The problem using a smartphone are different problems. First of all, not all persons have a smartphone. If you think about old people, they don't have a smartphone. They don't use them. They just use some old-fashioned phone. So maybe for them, it's not the right solution. Another problem is that even though we got smartphone, okay, sometimes we switch on, we switch off the app, the application, deputed to monitor the social distancing. So if we switch off, of course, in the switch off period, the system is not able to collect even precious data. Again, using the current application, the system is not able to detect current activities. We don't know anything about the activities. We just know something related to, the position or the mutual position. Stated first that the Bluetooth radio is accurate enough, and we know that it is not accurate enough. Okay, if I'm here and someone on the above floor got the radio open, I could have the chance to detect such people, to detect such smartphone. But I'm at home, at my home, and he or her is at his or her home. So we need to be very careful, okay, in managing data that could be at the source completely incorrect, okay? And then we need the new devices. In my opinion, we need the new wearable devices that we can, we can attach to our wrist or inside our clothes, and they are always on in such a way to provide 24/7 information without being able to switch them off and on, so causing, wrong collection of data or no collection of data. So this is something that, of course, could impact on our freedom to do many things, but very likely in a lockdown period, we need to act sometimes in a strong way in order to be much more effective and save a lot of lives, okay? Okay, so what are the requirements in my opinion? The use of wearable-based sensor, so not just smartphone-based. We need some wearable gadget in order to support this idea, and we need to be able to recognize multi-user activity. Maybe in a future world where we also got, IoT dense environment, we could profit. So we could profit even from an IoT dense environment in the streets, in a mall, at home, at the school, at the office, and so on and so forth. But we are very far away, you know, from this, you know, future in which an IoT dense scenario will be present. And of course, we need to record, we need to signal, and we need to think about also how to preserve privacy. But you know, there are many protocols already around that we could reuse. Just this is the last architectural slide. So we are developing a system completely based on body sensor network approach, collaborative body sensor network approach, fulfilling all requirements I mentioned before. And this will be, in our opinion, a tool that could be in the next year experimented, that could be very useful, very likely in a next pandemic event, not just for this pandemic event that, you know, we are all hoping that it will, you know, be stopped soon. But in my opinion, we need to be ready, we need to be equipped, okay, for a next event or for a next wave of this event, okay? So body sensor network, collaborative body sensor network, able to implement all the requirements I mentioned before. So to conclude, in this talk, I introduced you the SPINE approach, so you can join our open community in order to use SPINE. That is, you know, free to be downloaded. I also showed you the collaborative version of SPINE, able to implement collaborative body sensor network application. So the CN system is just an example of the tools you could be able to implement using C-Spine. And currently we are implementing the aforementioned C-Spine based system by putting together all, you know, our efforts so far. So putting together frameworks related to building networks, frameworks related to IoT networks, and even frameworks related to make IoT systems in a huge IoT system scenario interoperable with each other. This is fundamental because in a near future, you know, IoT will be massively heterogeneous, based on many different heterogeneous components and protocols. So we need also to deal with, you know, interoperability in order to create new tools to fight and combat efficiently and effectively, I would say, future pandemic events. And I'd like just to show you our series, IoT series. If you'd like to propose some book on IoT, recently we approved a book on IoT technology for fighting COVID-19. And, you know, this is, in my opinion, a right way to advertise research work, to promote research work, and to make such work reaching many people. You know, the series is Scopus indexed, is EI Conventex indexed. We already published 20 books and we got 15 books on the queue. So I warmly invited also you to propose some interesting book proposal. Thanks a lot for your attention. Thanks a lot.
Thank you, Professor Giancarlo, for your elaborative discussion on the system spine and the collaborative spine system that you have developed. We really appreciate your hard effort for producing the innovative solutions and that would help our community to further spread the COVID-19. May I now ask the participants to make question? So should you have any question, please raise your hand and make the query. Okay, I do have one question. Professor Fortino, you have emphasized on multi-sensor collaboration and research challenges related to this is data acquisition and synchronization and proximity analysis. I was thinking about a crowdsourcing technology. How about using body sensor devices as well as the mobile applications to crowdsource data from patients, their neighbors, hospitals, test centers in a cloud data center and analyze them to make demographical distribution and to make awareness among the community? And how can we interrelate the multi-sensor collaboration related applications and crowdsourcing applications together to further mitigate the challenging problem?
Yeah, thanks a lot for your question. I fully agree with you in the sense that, you know, in my talk, my focus was just on collaborative body sensor networks. In my opinion, collaborative body sensor networks are just a tool among many different ones we need to exploit in, I would say, in a synergic way. So not just collaborative sensor networks, but also crowdsourcing based on some mobile application, okay? And maybe in the future also using some environmental intelligence based on different kinds of devices. Indeed, currently there are already developed systems based on integration between body sensor networks and mobile applications, and as you said, crowdsourcing. Okay, so such data are pushed onto the cloud or even at the edge. Okay, and then analyzed in order to provide information. We already have several prototypes in this direction. Body Cloud is such of prototypes able both to capture data coming from body sensor network, but also data coming from mobile apps, okay, just from smartphones, and redirect such data onto the edge or onto the cloud, okay? For example, with some of my colleagues from Shenzhen Institute Advanced Technology in China, we used such a kind of system in order to really collect data coming from the body, coming from mobile app in the real COVID-19 scenario. And my colleagues there are analyzing the data in order to provide information from one side, but also to create models, simulation models, okay, realistic simulation models on the basis of which you can understand much better the real dynamics of the pandemic phenomenon.
Yeah, thank you, Professor. Is there any comment or question?
May I ask a question?
Yes,
This is
yes.
Sharia Rahman from University of Liberal Arts, Bangladesh.
Yes, please.
I have actually two questions. Number one is regarding the compliance with GDPR. One of the regulations given by GDPR is a user should be able to opt out from a system, if he or she wishes to keep her privacy. How do you address such issues? Do you have a privacy by design approach? And number two is, if it is a collaborative network, body sensor network, then what if some of the sensors get compromised, and they keep sending misinformations to the whole network, resulting into different information altogether. Thank you.
Okay, thank you for your questions. Very, very interesting questions. The first one was about privacy. The second one about fault tolerance. Okay, about privacy, you know, I'm in Europe, so I have to play with the European rules, and European rules are based on GDPR, okay? So indeed, there are many different protocols that we could use. For sure, we cannot enforce, okay, people to always switch on, okay? We cannot enforce because, you know, people could be able to even opt out and opt in, okay, as you say. So this is something that could compromise the overall network in terms of efficiency and effectiveness. Currently, of course, we are working on a prototype, and in the prototype, we are embedding the capability to opt out, okay? So, of course, we cannot do in a different way. So, anyway, our prototype will have this possibility, okay?
Okay.
The second question is about fault tolerance. Fault tolerance is important. We worked on fault tolerance in body sensor network using some autonomic approaches. Because, you know, sometimes we don't know whether or not the data that are being collected could be, you know, corrupted or could be the right one, the corrected ones. We don't know, okay? And we need to include in the system components able to understand whether or not the data we are collected are correct or not, are corrupted or not. So we indeed, some years ago, developed an autonomic component able to understand in action recognition applications the quality of the collected data, okay? And such component was able to mitigate, let's say, possible corruptions of data or possible issues with collected data. But anyway, your point is an important one, and this should be dealt with an automatic means, okay? We cannot do it manually because it's gonna be almost impossible. As you may know, collaborative biosensor network should work in real time. So it's important to introduce a fault tolerant component able to understand corruption of data or issues in general related to data collections.
Thank you.
May I ask one question, please?
Very briefly, because we do have two other speakers. Please.
Okay. Okay, I'm Dr. Ghulam Kibriya from University of Liberal Arts, Bangladesh. Actually, I have the similar question of Dr. Shahriar regarding the data privacy, and another is the data security issue. And other thing is that how do you consider interoperability issue, because different countries, the people are connected. It's about the body sensor network. So how do you consider this interoperability issue?
Okay, I will just focus on the interoperability because, okay, I already replied to the GDPR, you know. GDPR is important for us, and then we have to be compliant. Interoperability is a big issue. It's a big issue. I was the deputy coordinator of a European project was a 8.5 million euros project. We ran for 3 years from 2016 to 2018, focused on interoperability. In my last slide about you know, future work, ongoing work, I mentioned the Inter-IoT project. In the Inter-IoT project, we focused completely on interoperability issues at different levels in an IoT ecosystems, from you know, the device to the ontologies. Okay, so this should be explicitly, I would say, addressed, because it's gonna be a very important problem, If you think about many apps, if you think about many protocols, if you think about many technologies, if you'd like to be interoperable and then to provide a holistic approach, and then if you'd like that your tool will work in the future, you need to deal with interoperability. And of course, you got two ways to deal with interoperability. The first one is to define standards. But the problem with standards, you know, is that you are not able to define standards in a short time. Sometimes you need 10 years to have standards, okay? And the second option is that you are able to provide the so-called voluntary interoperability. So if you'd like to interoperate with me, we need to follow some, let's say, gateway-based method, and then we can agree to use some kind of gateway, some kind of broker, some kind of mediator. Okay, this was, you know, the solution we provide in my H2020 project, and indeed the solution works because it allows to create federations. So you can overtake the interoperability problem and issues using some federation-based approach, not based on standards. But again, interoperability is and will be a very big issue in the IoT area.
Thank you very much, Professor Giancarlo, for your valuable time and taking part in live discussion session. So we are moving to the next one. So our next speakers. May I now request Dr. Aminur Rahman to introduce Dr. Fahim Kausar.
Okay, thank you, Professor Dr. Muhammad Abdul Razzaq, Honorable Pro Vice Chancellor, Green University of Bangladesh, for giving me the opportunity to chair the session along with you. We are very glad that we have got Dr. Fahim Kausar with us in this session. He was also one of the keynote speakers of our last international conference, STI 2019. Dr. Fahim Kausar is the founding director of Pervasive System Research at Nokia Bell Labs, Cambridge. UK holds a Design United professorship at TU Delft, Netherlands. He spends most of his time at Cambridge building sensory artificial intelligence system with novel computational forms to explain human behavior with other people, places, and things. Fahim is a frequent keynote speaker, co-author, author, 150 plus publications, filed 30 plus patents, is an AEIC of IEEE Pervasive Computing, sits at the editorial board of ACM IMWT, serves as a committee member of leading mobile and ubiquitous computing conferences and had multiple million-scale projects commissioned. Now, I would like to enjoy our registered participants to enjoy his session. Thank you.
Well, thank you, Dr. Aminur. We do have another speaker from the same organization, Dr. Akhil Mathur. These two speakers will jointly talk on a single session. Dr. Akhil Mathur is a principal research scientist at Nokia Bell Labs in Cambridge, where he does research on mobile sensing and deep learning for edge devices. Previously, he has done research in the fields of ubiquitous computing, human-computer interaction, and technology for development. Mathur is a member of the ACM Future of Computing Academy and serves on the editorial board of ACM IMWG journal. He has been awarded with the billionth award South Asia Wolfram Fellowship at the University of Toronto and the President's Gold Medal for his undergraduate studies. His research has been covered by several media organizations, including the New York Financial Times, Live Mint, and Canadian Broadcasting Corporation. So may I now request Dr. Akhil Mathur and Dr. Fahim Kausar to go for their joint presentation. Welcome.
Thank you very much. So how much time do we have?
You can spend some 40 minutes together, 45 minutes, it's okay.
All right, perfect. So thanks a lot for inviting us and giving us an opportunity to talk about some of the research in the context of this pandemic that we are all experiencing across the world. Now, together with me, I have Akhil and myself. We work on sensor systems, and we've been doing it for quite a many years now together, and we thought it would be a nice opportunity to talk to you guys together. Akhil, maybe you can spend a couple of minutes introducing yourself briefly.
Yeah, so thanks again for inviting me. And as Fahim said, I've been at Bell Labs for 8 years together with Fahim, and we have developed a number of sensory systems based on machine learning, based on mobile sensing. And today, again, as the previous speaker, Professor Fortino, also spoke, like a lot of this research was done before COVID-19, but we will try to give you some perspective on how this research could be repurposed or extended in the post-COVID-19 world. Thanks.
So every day when I wake up in the morning, I get very depressed. This website makes me very depressed. And I'm pretty sure it's not only me, everyone in this call feel the same. But what is going on around us is basically unprecedented. And I don't think last year around this time, any of us in this call actually thought that this can happen in 2020. But unfortunately, that is the case. Now, we are not the real doctors. We are sort of like a fake doctors because we don't have the ability to understand human bodies and create vaccines or medications to really help the society in this crisis moment. However, we do have some research background, and we thought what we could do if we have to do some form of intervention to reduce this crisis to an extent that it can be manageable. Now, I think it's not a surprise to all of you that there has been some remarkable advances in artificial intelligence and sensing systems over the last decade. We thought this would be a very good opportunity for us to revisit some of the past work we have done in these topics, where we combined state-of-the-art machine learning with state-of-the-art sensing systems to address a number of different human societal issues, which could be very useful for this particular context. So Professor Fortino gave a very nice introduction of a number of different facets that could be achieved by using body area sensor networks, infrastructure sensors, and so on. Today, we're going to talk a lot about those things. Here is just a proposal that if you do cross-modal interaction modeling, you would be able to understand a lot about how people interact with other peoples and people interact with other objects, those might carry the virus and might cause spreading the virus further. But understanding these people-to-people and people-to-thing interactions, you might be able to offer interventions that might reduce the spread. For instance, you could provide early forecasting, you can provide sort of like a notification when people are violating the distance measures, the social distance measures that are being imposed by different governments. You might alert people based on the acoustics or the ambient temperature of an individual. You can support a variety of alert measurement for crowded places like in a meeting room or in an elevator, and so on and so on. But hold on a few moments, because we want to explain that how these different use cases could be achieved by some of the past research that has been done in the field. So we will talk three things today to you briefly, and hopefully these three topics will give you enough ideas that how some of these use cases just I mentioned in the earlier slide could be realized. So we're going to talk about how sensory AI could help workplace safety so that we can go back to our workplaces in a safe and practical manner. We're going to talk about how sensory AI could help us to be on control of our personalized well-being. And we'll also talk about how sensory AI could help us to offer citizen-scale behavioral interventions, which at this point is extremely important and critical. Now, I'll start with the first one. Over the last 6-7 years, we've been working on a project which is called Quantified Enterprise. And the objective of this work was really to understand how people interact, spend time, and dwell in their workplaces. Our objective was not for COVID. It was never for COVID. I hope not. Our objective was to basically understand how idea flows in an organization, how productivity could be quantified, how collaboration could be improved. And all these are essentially a very important aspect for an organization. So if you think today, people are the most important asset in any company, and we would like to support the growth of those people. And this project was really aimed at those facets, that by interaction modeling between people to people and people to place and people to things, can we actually offer some form of growth feedback to individuals. We were very inspired by a couple of works done by the literature. So Ben Weber, together with Sandy Pentland in MIT, has done a fantastic work with respect to people analytics towards the end of 2010. And this book essentially is the manifestation of that research, where it demonstrated that how by understanding human connections, you could expose a completely brand new value chain for the companies. And then these two recent books came out over the last 2-3 years, where they really talk about why we go to a work and what actually attracts people to a workplace, and how a workplace could be redesigned, remodeled, reshaped, that innovation can happen faster, quicker. Productivity could be the motto of every single individuals. And Raphael's work, which just came out last year, it really talks about workplace well-being. Mental health is an important issue, and more than ever, we are now worried about our health, not just physical health, but mental health. And this book gives us a very interesting perspective to how to promote mental well-being in workplaces and to support human potential. So those who are interested in working in this topic, I highly recommend you to read this book. So we started looking into this interlinked problem. Essentially, we wanted to understand how people interact in the workplaces, and there are quite a number of different sensing options you could take. Professor Fortino gave a very nice overview earlier today. You can go with mobile sensors, using your mobile phone. You can use wearable sensors like your smartwatches and so on. You could use cameras, infrastructure cameras, or you could use some form of RF sensor like Wi-Fi and so on. But essentially, when you think about this interaction modeling, the key piece of information you really need is collocation, or location as a derivative of collocation. And once you have that piece of information with some derivatives, you'll be able to reliably extract quite a number of important behavioral attributes. For example, with location, you can understand the physical state of use of a physical object, if the object is moving or not. By understanding location and co-location, you can understand when people interact with each other. And I'm going to talk a little bit about it. By understanding location trajectories, you can understand whether people are walking, standing, they're going upstairs, downstairs, whatever. Even those are very subjective, but at least we have demonstrated that by only using location data, you would even be able to extract an individual's personality types and could basically intervene to promote happiness and so on. So how did we do this? So we also applied a number of different mobile and wearable sensors. We started with the mobile phone applications, and as Professor quite high, and because of that, many user drops out after a while. So we needed to sort of like tap into some sort of forms which people use for a different purpose, and we can reuse that form for gathering this kind of sensor data. So we designed a number of wearables. One of them was a badge, and Akhil later will talk about another form that we did for our earbuds or wearables, as I call it. But this badge was essentially an access card that you all have when you go to your workplace today, and that gives you access to your building. And we just repurposed that wireless card, and we put a Wi-Fi SoC on it with a couple of sensors, so that suddenly it becomes a kind of like a cognitive badge, that it can understand your pattern of movements and your motion vectors. And based on your motion vectors, you can actually understand where you are in the space. We leverage Wi-Fi probes. Wi-Fi probes are kind of like a management packets that are used in a de-associated manner. So you do not necessarily have to be connected to a Wi-Fi gateway, but the badge would still release some sensor packets that can be captured by the infrastructured gateways, and then you can process all this information to basically offer some form of feedback that we're talking about. So let me give you some example that what you can learn. I mentioned to you about face-to-face interactions. There is a very concrete example that how you could learn face-to-face interaction by using your co-located packet structure. So by just looking into very simple first-order derivative of RSSI, not just the absolute RSSI, by the change of RSSI, for example, or change of your CSI, which is the channel state information, you would be able to identify a group of people. And once you identify a group of people, you can then go back to social science and learn from very interesting theories written by a number of social scientists, and more prominently Michael Goff, where there are three properties of face-to-face interaction: the group formation characteristics, the size, and the duration. These carries very important attributes of how face-to-face interaction is formed in a social place and how they deformed over the time. And you can actually model these things even very, I would say, logically, without using some form of machine learning inferences. So by using just very statistical like the log hoods, you would be able to detect when a group is formed and so on. So we have done some very interesting research around this topic, and we have seen that by using our technique, we were able to capture almost 60% physical encounters with a 90% accuracy. And once you have that face-to-face interaction being detected, what you really get is basically a physical graph of people's interaction. And then you can apply a number of different graph theory principles. Some of these we came up with, for example, if you want to identify how frequently an individual meet with other and how much time they spend with another individual, we came up with some sort of metric which basically characterizes this aspect. And I think many of you know about entropy, one of our Bell Labs invention. Entropy can also be used for identifying diversity. So the diversity is essentially, how rich your interaction graph is and how evenly you are interacting with those, nodes in the graph. But by applying interaction diversity and interaction intensity, you would be able to reliably understand that how people interact and with whom they're interacting and so on. Now, you can clearly see that this information gives you a very nice mathematical forms, which will allow you to do, for example, if you want to do contact tracing, which is just not based on pure proximity, but rather more informative, because then you have a way to explain what happened in those interactions. We have deployed this kind of systems in multiple locations of Bell Labs over the last several years, in Dublin, in Cambridge, in Antwerp, in Belgium. We offered a bunch of metrics to people so that they can really address those aspects of their life and can improve on, because everyone wants to become better in their workplaces. So how we could actually offer this kind of feedback so that they can take more informed actions. We also offer some sort of global scale view so that people understand what's happening at a billing scale. So you can immediately understand, like a map like this could be a very interesting story in a situation like where we are now, that if there has been a person with infection, you can immediately mark that place as a red zone, and then people can immediately see what the action they need to take and so on. We also went this kind of technology outside, and it was in Web Summit 2015 when we basically capture the interaction patterns of different individuals, investors, and entrepreneurs, and we try to model their behavioral traits, and we provide some sort of feedback that was very useful for the organization to redesign the space for the next generation conferences and so on. And also in 2017 in Mobile World Congress, which probably you know is the biggest conference, one of the communication companies, where we base model to talk about a bit on the personalized well-being, and then I'll come back that how we can connect the dots together with respect to the situation we are in. Akhil, you want to take over?
Yes, Fahim, can you maybe unshare your screen?
Yes, I can.
Okay, thank you. Can you see my screen?
Yes.
Okay, perfect. Yeah, so Fahim talked about a lot of scenarios that we have done for enterprise settings in a workplace, how you can detect people's interactions, people's different co-location behaviors, etc. What I'm going to talk about now is how we can use the sensory AI systems that we have today and repurpose them for our personalized well-being at an individual scale. So firstly, I'm going to say, so today, like most of the sensing happens on a smartphone. But in a post-COVID-19 world, I don't know if smartphone is the best tool out there, because we know that this virus spreads through our hands prominently, and the main modality for interacting with the smartphone today is touch and through our hands. So it's an open question whether smartphone will remain the device of the future, or will we expect, or will we see new form factors emerge as the society moves on. So one bet that we have as a team and as a group is that the earables, basically ear-based devices, will become prominent, and they may become one of the primary sensing modalities for end users. So earables have several benefits, right? So we already know that they have an established purpose, which is to listen to your music. And so the question that we asked ourselves as a group is, can we actually augment these earables with some sensors? And by augmenting them with sensors, can we ensure that they have similar capabilities as today's smartphones? And the result of this inquiry was this earbud that we created called eSense. The website link is not here, but if you can go to esense.io to get more details about the earbud. But these are, again, you can play the music with these things, but they also have integrated sensors, which include accelerometers, gyroscope, and microphone, along with Bluetooth low energy radio, which you can use to communicate the sensor data, like the accelerometer, gyroscope, and microphone data with a base station or with your smartphone. We have already donated these sensors to more than 75 research groups around the world, including some in Bangladesh. And a lot of researchers are actually working on these devices to create new kind of sensor applications. So I'm going to give you some examples of what can you achieve today with these earbuds and how potentially they can help with coronavirus detection, let's say. So the first thing that we tried to do was a very simple physical activity detection. So for example, if you're walking, running, or when you're making some head movements like nodding or shaking, these kind of gestures, can you detect them with the earbuds? And it turns out their earbuds are very accurate at doing these things. Even in some cases accurate than your phones and your smartwatches. And the reason being that because your human ear is a very stable part of the body, the degree of freedom here is much less than as compared to a smartwatch or a smartphone. We found that the kind of accuracies that we can get for physical activity recognition with the earbuds are much higher. Of course, the earbuds can't do everything. Like if you are moving your hands, the earbud cannot detect it, but at least your whole body motions can be detected with the earbuds and to a very good degree of accuracy. And to do so, again, we tried simple statistical features and combined them with shallow classifiers like nearest neighbors and even deep learning based classifiers to detect these physical activities. So this is just an example of how an application like activity recognition that we are used to having on our smartphones can potentially be replaced by using a sensory earable in your ears. Another example that we tried was about detecting a user's conversation. So when you're speaking, can the earbud detect it? And you can imagine the obvious answer is yes, because it has a microphone. So it can, of course, it can detect when you're speaking. But that's not the most interesting part. Like detecting a user speaking requires you to keep your microphone on all the time. And those of you who have worked with microphone would know that microphone is a very expensive sensor. If you continuously sample it, it can drain the battery in minutes, in hours, basically. So that's not a good solution. But interestingly, what we found was that because these earbuds have accelerometer and gyroscope, we can actually use these motion sensors to detect the user's speaking patterns. So just to give you an example, let's say when you're speaking, there are some movements in your facial muscles, in your jaws, and those muscles can actually be captured by these IMU sensors in the earbud. And so they can provide like first level of filtering. So whenever you detect these kind of facial movements, then you trigger the microphone sensor to detect a user's spoken sentence, for example. And using this kind of multimodal sensing, you can do your task at hand, which is the speech recognition, but do it in a very energy efficient way. Now, again, putting this into context for the COVID scenario, you can think about detecting whether a person is coughing or not. Now, again, coughing can be detected with a microphone, but you don't really need a microphone all the time. When a person coughs, potentially there will be some signature of a coughing in their face, in their facial muscles, and that could be captured by the sensory earables, which can then be used to trigger the microphone as an expensive sensor. So these are just some examples of how you can repurpose these established form factors and use them for interesting new sensing applications. And then, of course, we created, once you have these kind of sensing inferences, we can serve them to the end users through mobile applications. And we have created a number of cool Android and iOS applications to support this information dissemination. But I'm going to talk about more about the research side of it, that what's next from here. So one of our biggest hypotheses is that, and we think it's already coming true, is that the future is multi-device, multimodal, and of personal devices. So what do I mean by that? So let's look at the first fact that future is multi-device. So in 1995, there are some studies which show that most people would not even have one smart device on them, one connected device on them. But fast forward to 2020, on an average, now people have about 6 smart devices on them. Even myself, I'm carrying several of them. So I have a ring on me, which can capture some sensor data about my sleep. I have my AirPods, I have my smartphone, a smartwatch, etc. So the point is that in future, a user will have multiple smart devices on them. And each of these devices will have different sensing capabilities. They will be running on different operating systems, different hardware. And so there will be a lot of computation redundancy in this way. Like different devices will have the same kind of sensor. Like, for example, all these devices will potentially have a microphone, will potentially have an accelerometer. So there will be redundancy, but there will also be this massive heterogeneity in these devices. And the question is, can we actually design our sensing applications taking these multi-device environments into account? The second fact that we believe is coming true is about the innovations in the battery capacity. So we know that algorithms and the hardware are progressing significantly, but the battery innovations have not done so significantly. And there is an increasing need to ensure that the kind of sensing systems we are designing are energy autonomous or consume as minimal energy as possible. And that's a big challenge going forward. And finally, as I said, we have to, if we go from today's paradigm where there is a single sensor which feeds data into a single machine learning model, and if we'll jump frog into the future where we'll have multiple sensors and then the data will also go into multiple machine learning models, that we believe is a key challenge of future for future researchers. So we have done some initial work to address each of these challenges. The first challenge that we addressed is about the challenge of data heterogeneity. So as I explained earlier, because these different sensors have different manufacturers, the data that we get from them is quite different. So for example, we did an experiment where we asked users to speak some keywords in their microphone, keywords like hey Siri, hey Alexa, and trained a keyword detection model using deep learning techniques. The interesting part was that we trained this model first on an iPhone 7 and we got about 80% accuracy. But when we deployed this model on a different smartphone, let's say a Samsung Galaxy S8, immediately we see that there is a massive increase in the error rate of this model, almost a 2 times increase in the error rate. And the reason is that because of these heterogeneities in the hardware, heterogeneities in the software processing pipelines, the machine learning data gets significantly deteriorated in the process. And these variations in the data is different for different devices. And that's why machine learning models of today cannot cope up with this kind of sensing heterogeneity. And just to give an example, this kind of sensing heterogeneity can increase the word error rate of today's speech recognition systems by up to 10%, which basically would nullify all the advances that we have made as a field in the last 5 years. So this is a very, very important challenge to solve. And we have again used some machine learning techniques based on generative adversarial networks to solve this kind of sensing heterogeneity. Without going into too much details, I will just say that we developed a solution which can translate the sensor data at real time, such that the sensor data starts appearing closer to the training distribution. In that sense, you can reduce the sort of divergence between the training and the test data and increase the overall accuracy of the system. If you're interested, we have published a number of papers on this topic at IPSN, so you can have a look or reach out to me later. Then second, we already also talked about the design for multiplicity, that you have multiple sensors on you. So how do we leverage these multiple sensors? So of course, the obvious and the naive solution is that we can just take data from all the sensors, feed them into some kind of machine learning model, and we get some sensing inferences out of it. But as you can imagine, this is a very expensive operation. Like sensing from these multiple sensors all the time is just a waste of energy, basically, because all these sensors have redundant capabilities. How about if there is a way we can select the best sensor at any given time? So if I'm doing activity X, if I have an automated way using which I can find out that maybe my smartphone is the best device to sense my activity X right now, and I can disable all other sensors to save their energy. On the other hand, if I'm doing some other activity and maybe my earbuds are the best device at the time, then I can disable the sensing on all other devices, including my smartphone, and save my energy. So again, we have developed some machine learning techniques based on active learning and CME's neural networks, which given a stream of sensor data, it can automatically assess the quality of each sensor stream and find out which sensor stream is the best quality. And only the best quality sensor stream gets processed by your machine learning models. And all other sensors basically are disabled for next, let's say 5 minutes or next 2 minutes, something like that. And by doing so, we can achieve significant accuracy gain and almost 4 times energy gain in a multi-device environment. Finally, I think in the previous talk also, a lot of people raised the question of privacy, that we really don't want to stream a lot of this personal data, which is health sensitive, outside of our smart devices. So can you actually process the data locally? And as you know, today, a lot of the processing happens through deep learning models, which are trained on cloud scale hardware. And they are not specifically designed for these small form factor devices like earbuds or smartwatches. So in our group, we have done some extensive research, and we were the pioneers in this field 3 to 4 years back, where we showed how you can take a cloud scale deep learning model and compress it and run it on very small form factor devices. So in the figure, for example, at the bottom left, you see that we can take a model which is almost 250 MB in size, and we can compress it to, let's say, 32 MBs with a certain accuracy drop budget. Now, a lot of these techniques are now commoditized in machine learning frameworks, but we were like one of the first groups in the world to actually develop some of these techniques of using model compression, model fusion, etc. So with that, I'm gonna add I'll just add one final thing about the battery aspect of it. So we are also developing techniques to improve the battery, the energy efficiency in the data acquisition process. So when you're actually collecting the raw data from the hardware sensor, can we actually make that process also energy efficient? And there we have techniques around sampling quantization and precision scaling that we use to reduce the power consumption at that moment and make sure that these kind of sensors can run in an autonomous way. And one of the manifestation of this is a smart camera that we are developing. And our hope is that this will be the world's first batteryless camera, which can basically do vision sensing without using any battery. It can just harvest power from solar or from vibrations and still do hours and hours of vision sensing. So with that, I'm going to hand over back to Fahim to conclude the talk.
Thanks, Akhil. If you stop sharing, I will take over.
Yeah.
All right. So, so Akhil has given some of the technical foundations that basically drives our research in this topic with respect to different forms, as well as the underlying machine learning principles that we apply for building multi-sensory, multimodal, multi-device systems. Now, I begin the talk by talking about how these things are relevant to COVID-19 situation that we are encountering today. Now, if I go back to this slide, which I showed earlier, I mentioned a number of use cases that can we detect an individual is going to face another individual within a certain distance, and we should nudge that individual so that he or she can take right action. You can now see that it's very easy using the technologies that we have been developing over the years. in a straightforward manner. You can understand the acoustics and the ambient temperature of an individual, and if it is at a risky level, you can easily alert the people nearby so that they can take proper actions. If you think about workplace safety with respect to handling packages or handling devices, because they require surface touching, you can immediately address these concerns by understanding an individual's exposure and take actions accordingly. So on the left side, I said that how you can achieve these things. You could apply vision, acoustics, wearables, as well as machine learning in a combination of these different devices to basically build this sort of applications quite straightforward today. The intelligence is where it plays the key role, and it's not very expensive systems either, right? Today you can buy off the shelf web cameras, which is less than $10, right? And you can install those cameras in your workplaces, and you can start serving this kind of applications in few weeks' times of development, which will help to basically reduce this infection spreading. Now, I want to now touch the last part of the talk very briefly, that so far we really talked about device-centric or sort of like a sensor-centric interventions. Of course, when you think about the citizen scale intervention that you have to look into entire populations, what can you do? So while we haven't done exactly for COVID situation, we have done work where we model wireless networks behavior. More importantly, how people use the wireless network. For example, their cellular network, how they make phone calls, how they use web. And this carries very important footprint with respect to individuals' personalized behaviors. So in this particular work, for instance, we looked into South Korea Telecom's mobile phone traffic, and we could reliably extract out how individuals move throughout the city, where they spend time, with whom they interact with, what type of interest that individual has, by applying a number of interesting machine learning models that we develop. And this is one example. So if today in Bangladesh, you have everyone, pretty much everyone has a mobile phone, be it a smartphone or a feature phone. So if the mobile operators actually expose their traces in a privacy-centric way, right, you should be able to anonymously identify potential hotspots that might appear in 10 days' time by just looking into the cellular phone traffic and the way calls are being made at different areas. Another project where we looked into travel network behavior. So this was work that was done with a collaboration with TfL. So the TfL is the Transport for London, provides the transportation service, both underground subways, overground trains, as well as the bus. And they use as a smart card, which basically people can use to pay. But that smart card traces gives us an interesting view on where people are moving from which area to which areas. And by modeling these movement patterns, we could, at this point of time, we could reliably understand how people use different amenities in a city, how their movement is triggered by different activities, and which part of the city becomes hotspot for which type of activities at what point of time in the day or in a week, so on. So this kind of geographical mobility modeling is, I think, a very important way to deal with this COVID situation, because you can understand we have very limited number of hospitals, we have limited number of beds, we have limited number of healthcare professionals. It is essentially load balancing problem, right? If you know that this part of an area is becoming hotspot today, and most of the people from this area is moving to these other areas, you can immediately take actions to make sure that you can balance the load of the patients in those upcoming hotspots in a more practical manner, right? So I just wanted to give you an example that where we have shown you some on-body sensor network or mobile phone-based applications. You can also look into this classical existing network, be it a travel network or cellular network or wireless network, and you can repurpose them to basically understand this population scale behavior, which will help you to intervene to manage this kind of infection spreading situations. So with that, I want to sort of like conclude by saying that while we are working on these topics, we are not the only group. I think many groups in the world are looking into this kind of topics for many years. Here are a few of my favorite examples I want to highlight. In your hand, you have a magical device. Your smartphone is equipped with a lot of sensors, and by applying machine learning techniques, you can do magic. For example, oximetry is an important diagnosis that needs to be done today to understand your oxygen level in your blood, because that's an interesting and important indicator. And you can use your smartphone's back camera or the front camera with some other techniques to basically understand your oxygen level, right? So there are a number of papers written. The one I refer here is actually from Microsoft that came out a couple of years ago, where they were showing that how you can use the front face camera of your smartphone to do oximetry. The next one is the spirometry, which is essentially assessing your lung condition, right? And this was was done by Shotak Patel's team in Washington University, where they created this 3D printed, like a whistle type of device, which allows you to blow in the device and listening through a microphone of a smartphone and then assess the lung conditions, right? So this is a very cheap and reliable way of providing medical grade diagnosis of your lung condition, okay? This middle one, which is one of my collaborator, my good colleague Cecilia Masolo's initiative, he recently started collecting large scale data from people's smartphone to analyze their breathing and like a coughing behavior. Akhil mentioned about the coughing can be easily detected with our earbud. Some of our collaborators who have used eSense wearables to basically monitor breathing patterns, coughing patterns already, and some papers are coming up so that you can actually look into that. It's very well, it's not straightforward, but it's not impossible. By using intelligent machine learning techniques, signal processing techniques, you could repurpose your smartphone and other smart devices to do medical grade diagnosis. And the top and the rightmost one is I think one of the game-changing technology that is being developed at Bell Labs by my good colleague Michael Eggleston to do optical coherence tomography. It's essentially piercing through your skin and understand how your body is changing with respect to different physiological phenomena that is going through in the body. Until today, the tomography was not possible in a mobile form, but Michael's work is the first in the planet that demonstrated that how you can actually build a handheld device that will allow you to do OCT, which I believe would be a very, very strong weapon for us to deal with the next pandemic. With that, I would like to thank again to Professor Rajak sir and his team to invite me and Akhil and give us the opportunity to talk some of our work. I hope this was useful, and I hope even we could inspire you with 5% of our work. We would consider this session was very successful.
Take us. Hello.
Hello. Yeah.
Am I audible?
Yes.
Thank you very much, Dr. Fahim Kalsar and Dr. Akhil Mathur for a nice presentation. And you have explored many sensory devices readily available with us, or very low cost devices, and how to repurpose those for multiple applications. You have explored many ideas. So may I now request our audience to make questions or comments. I have one request from Professor Dr. Atikur Rahman Ahad, now from Osaka University, Japan. Please.
No, thank you, Professor Fahim Kausar and Akil Mathur. So my question is that, I mean, have been using your wearable device for some activity recognitions. While working on that, we have found that eating versus speaking, we get more confusions. What do you think about the reasons? Because it has very impactful applications, we think, on the hospital patients or elderly people. So when they speak and when they eat, I mean, we get some confusions. And number two, related to this, what are the most successful applications based on this, you think, for the future? This is my queries. Thank you.
I will take that, Akhil. I think the problem of eating and speaking, it's a common problem simply because you have multiple events in one signal stream. So you probably have to look into your signal processing pipeline. I'm not sure what pipeline you have used, but techniques like ICA, where independent component analysis is applied to basically separate the different frequency bands with respect to different activities, might be one way to look at it. Now, what actually happens when you eat or you speak, your zygomastic muscles in your human face has some impulse response, and that is what we are capturing in the IMU through our wearables. One suggestion I have is that there is a language called FACS, Facial Action Unit, which is used in animation engineering very deeply to create human-like expressions in animation characters. And they have divided our human face into 28 small blocks, where each of those blocks micro expressions can be captured. So we have written a paper last year or 2 years ago on that front, but we could only do, some of the AUs, some of the action units. But I think another way you can look into this problem is by applying these action units principles and trying to divide the different events into these atomic micro expressions, and then build a higher level activity, which is eating or speaking on top of that. So these are my two suggestions, that try to see if ICA can help. And then second is that apply the FACS principles to divide the atomic expressions into more atomic ones.
Yes, thank you. But just a little bit different, my question was, sorry, I was quick to ask that we have recognized different kind of classes, but when all are separate classes. So when there is a speaking class and eating class separate, but in the confusion matrix, they confuse each other. So it means that definitely our method cannot determine, but whether the eSense device has something that this kind of similar movements are not separable or anything like this, because you organized the workshop last year, so you know much more on all the other different methods. So that's why I'm asking that, why is that those two classes specifically are confused more than other classes? Thank you.
I think,
are you using audio or IMU? If may I...
Thank you. We are using the IMU. Yeah.
Okay, I see.
So I think, Harpai, we have to talk offline on this, because as I said, that the phase response from these two type of activities are very similar. So you probably have to, I mean, I'm just coming up with all these ideas, that you have to probably do a two-level, inferences probably. First, to classify that this is eating and speaking activity or non-eating and speaking activities, and then for those you apply a secondary pipeline which can further separate these two signals to some extent. And then Akhil bring a very good point. Maybe applying audio together with IMU might be another interesting way to deal with it.
Thank you. Thank you.
Thank you, Professor Atik. May I now request Professor Dr. Shihabuddin from the University of Bangladesh to ask question.
Thank you, sir, and thank you, Dr. Fahim Kausar, sir, and Akhil Mathur for this wonderful presentation. And I'm really glad to see Dr. Fahim Kausar, sir. You were one of my first university teacher back in 2003 in IUT. I was one of your students. You might not remember me. It's very good to see you, sir. So I have two short questions. One is, because I saw that you're using face-to-face interaction to kind of relate it to the happiness and also do some intervention based on that. So I was a bit curious, what types of intervention that you'd advise to maybe improve a situation inside a household environment, and what types of, I mean, like we get all this data, but what types of interventions do we normally take to improve a situation? And the second question is, I see a very, very nice work that you have been doing, and which makes us very much interested to somehow collaborate or get involved in some sort, because I mean, in Bangladesh, we often lack an opportunity to work in such a state-of-the-art level of research. So I would be very curious to know, is any possibilities from your lab, or is there any way that we, if some of us would like to contribute or in some part of the work that we like to engage in, is there any possibilities or arrangements that could be made? Thank you.
Thanks a lot, Shihab. So on first question, so the intervention is very personalized facet. Every human being is different, so you can't really have a set of generic intervention that will work for everyone. As I say, that when we were looking into this particular problem, that I always believe happiness is a very strong keyword which will form the future research. So we try to understand that what causes, for example, certain type of motion behavior when people are depressed or down or sad, and what sort of like it brings best out of you with respect to, let's say, your motion behavior or productivity and so on. And then one of the things that we have identified through studies that the interaction plays a very key role, and I think many of you will agree with us, that individuals you meet, there are people who makes you happy, there are people who makes you incredibly positive, and there are also people who are sometimes not very positive and everything in the life is not so bright for them. So avoiding interactions or avoiding longer interactions or frequent interactions that creates a consequent, episodes, negative episodes in your personal life was one of our interesting identification from the research, and that is something that we sort of like looked at, that in our this frequency timeline we recommended that you these are the people might give you more positive energies. The other thing we also looked at is your physical and in some form of motion activities, because that's a very strong indicator of your state of mind. So if you move, if you go outside, if you take a walk, if you drink a bit of more water, all these things actually contribute to your overall well-being. So I run a workshop at UBComp every year called Welcome, Wellbeing Computing. So you are very welcome to come and join us in that event, where we actually study that how these different facets with respect to recommending people to do some form of physical or mental activities, to sleep properly, to eat properly, avoid negative contacts, can help people to improve their overall well-being. Okay, then when you go to the workplaces, it is also like a So not because many of you, basically all of you here, I believe, are knowledge workers. So you work in a more independent manner on in a knowledge-driven jobs and so on. But people who does more repetitive jobs or manual jobs, many of those people suffer from depression and suffer from other mental health diseases like bipolar, extreme cases, and so on. And you know, it is very hard today to basically diagnose this thing. So technology like what we are promoting here could actually help people to have a self-awareness. And once you have the self-awareness, that is the very first stage of any kind of intentional behavioral change. So we believe that this self-awareness will give them a bit more control of what they should and they should not do, right? But again, it's a very, I would say, current topic in terms of behavioral intervention. There is no, I mean, correct answer. I think it is very subjective and it depends on individuals. And
if I can quickly add one thing to what Fahim said, again, today in the COVID world, we are all sort of living in this isolated world in our homes, and the social isolation also becomes a major problem for vulnerable communities such as elderly people or people who already have mental illnesses, right? So again, if we can detect these kind of behaviors creeping in some people, then we can possibly have some recommendations about social contacts, maybe not physical contacts, but like video calls or something for the elderly to talk to their grandchildren, things like that. So again, that's not my research area, but I believe there is a lot of research on intervention design in human-computer interaction, which can be combined with a lot of the sensing technologies we are developing to create like holistic solutions.
And your second question with respect to collaboration, so there are many forms. I mean, of course, my industrial position does not allow me to have a lot of collaborations because of, you know, you work for a company. But we do have a very strong internship program, as well as we have, you know, like a informal collaborations when we have a great idea together. We often typically write papers together with you know, different schools and so on. And on my academic hat, when I talk from a TU Delft professorship point of view, there it's a bit less, I would say, complicated, and there, we are very open to work with other universities, you know, build collaboration, build, you know, joint programs and so on, student exchange programs and so on. So it really depends on, you know, which type of work you are interested in and what type of mechanism works best for both the organizations.
Thank you, sir.
Thank you, Professor Fahim and Dr. Akhil Mathur. Is there any other question or comment? Ubaidur Rahman, please. Professor Dr. Ubaidur Rahman, please.
Okay, thank you, Professor Fahim Kausar and Professor Akhil Mathur. I think you can hear me, right?
Yes, yes.
Okay, so thank you, Fahim Bhai. Actually, I'm also from CIT 99. I think you can recall me that you can recall me as an athlete from the athletics round of IIT. Anyway, currently working as a professor in CSE department at DUET, where. So my actually I have some from the not that much technical. The question is that from the time that COVID has started, we have seen that lots of tracing is going on using mobile devices or the technical devices. Suppose in South Korea, they have tracked and traces the patients, and sometimes some personalized data are being forced to they collect Thank you.
Thank you, Professor Ubaid Rahman. Should you don't have any other question, I want to request Professor Giancarlo Fortino to make some comments, final comments. Professor Fortino, you are here. Professor Giancarlo Fortino, your microphone is muted.
Rajak bhai, Professor Rajak,
Yeah.
I have a questions if you allow me.
Okay.
Okay. Thank you. Because it's not easy to get a person like Fahim Kausar. So my question is that researchers, we are exploring multimodality and fusion, this kind of things again and again. But I find that it is extremely difficult and rare as well, especially vision-based and wearable sensor-based domains. So would you please explain, give some kind of insightful points on where we can make, fusions or multimodalities, or what kind of domains this is dominating now and in the coming years? Thank you.
So these are our current research topics. We're writing papers about it. Ahad bhai. So Akhil and I am smiling because these topics are really what we've been exploring, and we've been building systems around it. I think there is a very strong push from the industry today in the industrial automation, or Industry 4.0, however you say it, for surveillance and supervision into enterprise environment. And by enterprise, I'm not just talking about building spaces, but more into factories, industries, as well as industrial transportations and so on. So when you look into this kind of facilities, privacy questions are not very prominent, because it's a factory space. You are basically offering safety and surveillance services. And there, I think the opportunity of combining multimodality like vision, acoustics, wearables are very, I would say, compelling cases. In the home environment or in a smart city environment, I think they are less, I would say, compelling, simply because the complexity and the privacy questions always play sort of like a decisive role. But when you go into this kind of industrial settings where your sole purpose is to offer workplace safety and minimize your CapEx and OpEx cost, I think people, including the decision makers, they are more willing to take actions and deploy systems that include such complex ecosystem of cameras, microphones, like wearable devices and so on. So I think that is an area which we will see a lot of growth in the next 2 to 3 years.
Thank you very much.
So thank you very much, and I would like to conclude now. Our special thanks to the learned speakers for your valuable time for us, and you have educated us. You have ignited some research directions to our fellow colleagues, and I believe our graduate researchers and young faculty members will continue their efforts on the emerging research problems you have explored. And definitely special thanks to Honorable Vice Chancellor of Gay University of Bangladesh, who paid a lot of time for his valuable schedule. Thanks to all the professionals, the researchers, faculty members from different corners of the world for a valuable time to make our event successful. And definitely special thanks go to the IEEE volunteers, the mentor, the volunteer students who worked hard for this to make this event a successful one. May Allah save us all from any diseases and health complications in future days. Thank you very much again, and have a good night. Allah Hafiz.
Thank you very much.
Thank you.
Assalamu alaikum.